Now what we're going to do is get over here and we're going to journal about energy. We've learned a lot of stuff here in the past couple of days. I'm going to make a scroll like she did on here. Why? Just because it's fun. Energy is the ability to... Oh, that said do. Do work. To do work. Energy is the ability to do work. Energy is organized into two categories. The first one is potential. And we've learned about this on Bill Nye already. If I tell you you have potential, that means you have the ability to do something. The other type of energy is kinetic. When you hear kinetic, I want you to think of motion. Potential energy is stored energy that could do work. Think about if you leave a pencil on your desk. It has the potential to move. Kinetic energy is energy that does work. Like if I bump the pencil, it's going to fall off your desk. Now I want to go to Carowinds for a minute. And I want to ride this roller coaster. So what happens is the roller coaster starts and they take you up this hill. And then it goes down really fast. My wife don't like it, but I love it. So when your roller coaster car is right here, does that have a lot of potential energy or a little bit? A little bit? Look how high up that is. This is a lot. Has a lot of potential energy. Now, when it goes down the hill, whee! What kind of energy is this? Huh? Kinetic. Because it's moving. What about when it's here on the top of this hill? Huh? Potential. That's not what we're doing, Law. What about right here? Or right here? If it's going down or up, these are kinetic. When it's here, it's potential. Does everybody understand? If you do, say yes, I understand. I don't know who that is, but we need to stop that nonsense. Then down here, we're going to make a picture, and we're going to call it inertia. And that was one of the laws. Which law is inertia? Remember, it's the first law. Something at rest stays at rest. Something in motion stays in motion. When you think of inertia, I want you to think of Miss Gibson. Because somebody had her a wreck. No. This is Miss Gibson in her wreck. Did I tell you she had a wreck?
No.
Some joker ran a thing and hit a car, and that car hit her.
Oh, and the inertia.
The inertia wanted to keep moving.
That's why you need your seatbelt so you don't fly through the windshield. It's about time for lunch.
Don't get them stirred up.
I'm hungry.
Here's a steering wheel.
What? Sustenance.
Here's a
Good word.
steering wheel.
Good word.
She said, "Ah!"
Oh, my ear. That actually
Now.
Don't let him fool you. That's what he would say too.
What? Who wouldn't? Who wouldn't say that? Okay, so this person has hit something and the car stops moving suddenly. Crash. What is this person's body going to do? This is why we wear a seatbelt. A seatbelt stops your inertia. If you want to be protected, wear a seatbelt.
You know what else will stop your inertia after a few moments?
What?
Bareback.
Just get it out and let's go. We are going to calculate speed. Calculating speed. Up at the top, over here, I want you to draw a pretty big triangle. And then I want you to make a small triangle and then cut this bottom part down here in half. With your first color, you're going to put a D right here. And D equals distance. In your second portion, you're going to put an S. And S means speed. And in your third portion, you're going to put a T. And T means what? No. How you calculate speed? Distance and time, right? Now, distance divided by time equals speed. Distance divided by speed equals time. Or speed times time equals distance. How beautiful. How beautiful does it get? We're going to have to finish it after lunch. So we're going to pick up here. The problem number 1 is going to say a car traveled 300 miles in 5 hours. Calm yourself down. How fast was it going? So we're going to use our 3 colors. 300 miles is distance. 5 hours is time. The speed is how fast. To find out how fast, you have to do speed equals distance divided by time. Well, remember how we used to make it be a fraction? We just finished doing that. Speed equals distance over time. What does that line mean? Divide. So it would be 300 miles divided by 5. So let's do 5 into 300. Can 5 go into 3? No, so I'm going to move that 3 over here. Can 5 go into 30? How many times? How many times? 6 times 5 is 30. That's 0. 5 goes into 0 how many times? So the answer is 60 miles per hour. Ain't that something? Next problem. A bus traveled for 6 hours at a speed of 60 miles per hour. You can do miles per hour like that, MPH, or you can do miles per hour like that. How far did it travel? Question mark. If it did 6 hours, that's the time. It did 60 miles per hour, that's the speed. How far did it travel is the question, so we're wanting to know the distance. If we have the speed and the time, what do we do to find distance? We multiply it. Distance equals speed times time. So we're going to do 60 times 6. What's 6 times 6? 36, and then you got to plug that 0 on the end of it. How far? 360 miles. And we're going to do one last one. How long would it take to travel I'll scoot it up in a minute. People are still finishing. How long would it take to travel 36 miles at 9 miles per hour? That's slow. My grandma goes faster than that.
Probably like that. That's sterile speeder.
How long? That's the time. So we don't know the time. Would it take to travel 36 miles? That's the distance. At 9 miles per hour. That's the speed. How do you find time? Time equals distance divided by speed. which would be 36 over 9. What's 36 divided by 9? 4 heirs. That's all she wrote.